A pipeline processor contains 5 instruction stages of execution times 120, 160, 105, 135, and 155 nanoseconds with a register delay 10 nanoseconds on each stage. What is the percentage of performance increased with 1000 instructions instead of 10 instructions? So we have a 5-stage pipeline. The processing delay within each stage and the register delay is given. We need to compare the performance achieved by 1000 instructions with respect to the performance achieved by pipelining for 10 instructions. We know that as the number of instructions increases, the performance achieved by pipelining can be increased. So first we shall calculate the performance achieved by pipelining for 10 instructions with respect to speedup. We know that speedup is equal to the execution time of non-pipelined approach divided by the execution time of pipelined approach. In non-pipelined approach, all these 10 instructions will pass through these phases one after the other. Hence, the execution time for 10 instructions is 10 into 120 plus 160 plus 105 plus 135 plus 155, which is equal to 10 into 675 nanoseconds. Now, if we are using pipelined approach, we use intermediate registers or buffers in between, and the clock period will be set to the longest stage delay. Here, what is the longest stage delay? It will be 160 plus 10, 170 nanoseconds. Hence, the clock period is set to 170 nanoseconds. And what the time taken for that pipelined approach? The time taken for the first instruction is the number of stages into 1 clock time, and for the remaining 9 instructions, the time taken is 1 clock time. So the answer is 14 into 1 clock time. 1 clock is 170 nanosecond, hence 14 into 170 nanosecond. Now what is the speed up for this 10 instructions in pipelined approach compared to the non-pipelined approach? Execution time of non-pipelined approach divided by the execution time of pipelined approach. 10 into 675 divided by 14 into 170. Answer is 2.836. So this is the performance achieved for 10 instructions with respect to speed up. Now we should calculate the performance achieved for 1000 instructions with respect to speed up. For 1000 instructions, the execution time of non-pipelined approaches, number of instructions into 675 nanoseconds. And for pipelined approach, the time taken is, for the first instruction, the time taken is 1 into the number of stages into 1 clock time, plus for the remaining 999 instructions, the time taken is 1 clock time, which is equal to 1004 into 1 clock time, which is 1004 into 170 nanosecond. Hence, what is the speed up for 1000 instruction? 1000 into 675 divided by 1004 into 170 nanosecond, which is 3.954. So we can see for 1000 instructions, we have a more speed up compared to the 10 instructions. And the question is, what is the percentage of performance increased with 1000 instructions with respect to 10 instructions? The percentage of performance improved is 3.954 minus 2.836 divided by 2.836 into 100, 39.42%.